Hello viewers, welcome to Climate Discussions. Today we are going to discuss a research paper titled Regional Precipitation Response to Regional Warming in Past and Future Climate. This paper was published in Pakistan Journal of Meteorology, Volume 11, Issue 22 in January 2015. The abstract says, regional precipitation feedback resulting through regional mean temperature escalation on seasonal basis has been investigated in this present study. Recently published reanalysis dataset EGNIRA has been used to cater for observational dataset requirements for analysis. Historical 1980 to 1998, present and near future 2007 to 2025, and far future 2080 to 2098 climatic datasets of a super high resolution GCM, namely GCM 20, at 20 km horizontal resolution with A1B scenario, and of a high resolution RCM, namely Rexium 4.3 at 25 km horizontal resolution under RCP 8.5 emission scenario have been used to construct linear regression models based on method of least squares to analyze possible regional precipitation responses to increase in regional temperature over Pakistan. Mean seasonal temperature have been used to predict mean seasonal precipitation feedback both in past and future climate over the region. Results have shown that March, April, May, hereafter MAM precipitation has the highest cumulative response to changes in daily mean MAM temperature, irrespective of the time period and the data used. EGNIRA reveals a 0.09 mm per day drop in MAM mean precipitation intensity for each degree Celsius rise in MAM mean temperature over the region. Under the A1B scenario, GCM 20 baseline and projection analysis depicts 0.12 mm per day decrease in historical, 0.09 mm per day decrease in present and near future, and 0.12 mm per day decrease in far future March, April, May mean precipitation intensity for each degree Celsius rise in MAM mean temperature over the region. However, under the RCP 8.5 protocols, Rexium 4.3 baseline and projection illustrates 0.04 mm per day decrease in historical, 0.04 mm per day decrease in present and near future, and 0.09 mm per day decrease in far future MAM mean precipitation intensity for each degree Celsius rise in MAM mean temperature over the region. The paper concludes with the following conclusion: a wider analysis over the distribution of the rate of changes and of their corresponding degree of variance explanation reveals that MAM season precipitation has the highest cumulative response to changes in daily mean MAM temperature, irrespective of the time period and the data used. However, the MAM temperature precipitation correlations get weaker with increasing projection time. Possible reason for this finding might be a time-oriented seasonal shift from winter towards spring in the projected mean annual cycle of precipitation patterns. Relatively marginal amount of variance explained by change in mean seasonal temperature that provides feedback to mean seasonal precipitation over Pakistan caters for induction of more variables as predictors in the linear regression model. By virtue of this, correlations with precipitation response are expected to get more robust and coherent. Our scope of using mean seasonal temperature as a predictor to mean seasonal precipitation response has provided us signatures that let us believe the adverse impacts of regional warming over regional precipitation intensity over Pakistan. Thank you for listening.